In this video, we're going to be looking at standard form. We're going to look at converting ordinary numbers greater and less than 1 into standard form. And we're going to look at how to use index laws to solve problems using numbers that are in standard form. Here we have a number written in standard form as 3.8 times 10 to the power of 3. There's two distinct parts to this number. The initial section, which gives us the digits to use, and the latter part, which tells us where to place the decimal point. The first part of standard form must always be equal or greater than 1 and less than 10. Therefore, it can never be more than just the unit's place value. If the power is a positive 1, we'll move the decimal point to the right, making the number larger. And if it's negative, we'll move it to the left, making the number smaller. So here we've got 3.8 times 10 to the power of 3, which we can convert into an ordinary number of 3,800 as we move the decimal place 3 places to the right. And we fill the empty place values with zeros. Here we've got 3.8 times 10 to the power of negative 3. We can convert it to 0.0038 as we move the decimal place to the left and we fill the empty place values with zeros. Also, put a 0 to the left of the decimal point to show that it's a decimal. Here we have the number 260,000, which we wish to convert into standard form. Remember, we want the decimal place to be after the first digit on the left that's greater than 0. So we're going to take the first two digits of 2 and 6, and we're going to put the decimal point between them, and then we're going to count back on the original number. How many places was it that we went back? 1, 2, 3, 4, 5. So we can write it as 2.6 times 10 to the power of 5, because it was 5 decimal places. Next, we have the number 0.00026 to be converted into standard form. So we're going to take the first digits, starting from the left, that are greater than 0, which is 2 and then 6, and we're going to put the decimal point between them. Now we're going to count on the original number how many decimal places we needed to move that point by. 1, 2, 3, 4. So we're going to write 2.6 times 10 to the power of negative 4. What we're going to do now is look at how standard form is used when we're multiplying. Before we do, let's just remind ourselves about how powers are calculated when multiplying, and the base numbers are the same. Here's the example of a to the power of 4 times a to the power of 2, which gives us a to the power of 6. As the base number is always in 10 in standard form, we can use this index law. Remember, if we're multiplying and the base numbers are the same, you can simply add the powers. So here we have the problem. In the first set of brackets, 1.2 times 10 to the power of 3 times, in the second set of the brackets, 3 times 10 to the power of 2. We can take away the brackets because actually all of the operations are multiplication. So we have 1.2 times 10 to the power of 3 times 3 times 10 to the power of 2. What we can do is now we can gather the terms together so the like terms are together. So we have 1.2 times 3, and then we'll have times 10 to the power of 3 times 10 to the power of 2. So now we've got the two numbers with powers and the base numbers are the same together. We can multiply 1.2 times 3 to get 3.6, and we can multiply 10 to the power of 3 times 10 to the power of 2 by adding the powers because the base numbers are the same, which is 10, and we get 10 to the power of 5. So we end up with the number 3.6 times 10 to the power of 5. This is great because it's already in standard form and the digits at the front are 3.6, greater than 1 and less than 10. As you could see, we could remove all the brackets as all the operations were multiplication. And we could then rearrange the numbers to make it easier to calculate what the answer was going to be. Next, we have in the first set of brackets 5.2 times 10 to the power of 3 times the second set of brackets, which is 4 times 10 to the power of 4. As it's all multiplication, we can take away the brackets to make it easier to rearrange. So 5.2 times 10 to the power of 3 times 4 times 10 to the power of 4. I can rearrange this to have all the digits together. So 5.2 times 4, and also so we have all the numbers with powers together. 10 to the power of 3 times 10 to the power of 4. I can multiply the first two to get 20.8, and I can multiply the tens together to get 10 to the power of 7. So I have 20.8 times 10 to the power of 7. Now this isn't in standard form yet because the number that we have before the times by 10 is greater than 10. So we're going to reduce that by dividing it by 10. Because I'm reducing that number down, the number of powers goes up. So reduce it down to 2.08, and the powers of 10 goes up to 10 to the power of 8, and we get the answer 2.08 times 10 to the power of 8. And now we can complete that multiplication to find out our answer. If you need to increase the digits, you'll reduce the powers, and if you need to decrease the digits, then you increase the powers. As you can see, calculating with standard form takes a bit of getting used to, but it can reduce the amount of time taken to do a large equation and give a good estimate of an answer to a problem that uses really large numbers. Now let's look at how we use standard form when dealing with division. Before we start, let's review the indices laws with regards to division of powers. When the base number is the same and you're dividing, you can subtract the powers. So here we've got a to the power of 6 divided by a to the power of 2, which gives you a to the power of 4. So here I've got 1.2 times 10 to the power of 7 over 3 times 10 to the power of 2. We can split these two sections up so we're dealing with them separately. So we can make it 1.2 divided by 3 times 10 to the power of 7 divided by 10 to the power of 2. What I can now do is if I can imagine 12 divided by 3 would give me 4, so 1.2 divided by 3 would give me 0.4. 10 to the power of 7 divided by 10 to the power of 2 would give me 10 to the power of 5. This still isn't in standard form though, because it's 0.4, so I need to increase that by a power of 10. So if I times that by 10, I get 4.0. Now because I've increased that by a power of 10, I need to decrease my powers of 10. So it goes from 10 to the power of 5 to 10 to the power of 4. So we end up with the answer of 4.0 times 10 to the power of 4. Now let's look at what happens with addition and subtraction using standard form. Remember, you can convert the numbers from standard form into ordinary numbers, complete the calculations, and then convert it back into standard form if that's how they ask you to give the answer. So for this problem, you can complete it as follows. So we've got 1.2 times 10 to the power of 4, which makes 12,000 as an ordinary number, and we have 4 times 10 to the power of 3, which is 4,000 as an ordinary number. If we add those two together, we get 16,000, and we can then convert it back into standard form by using the first two digits that we come to, which is 1 and 6. We place a decimal point after the first digit, and then we see we can go 1, 2, 3, 4 decimal places, so it's times 10 to the power of 4. So this gives us the answer of 1.6 times 10 to the power of 4. So in this video, we've looked at converting from ordinary numbers into standard form and then back again. Remember that positive powers make the number larger and negative powers make the number smaller. We've also reviewed how to use the indices laws to calculate numbers in standard form. So the next video in this series, we'll be looking at the foundations of algebra and how we go about using variables in equations. I'll see you then.